A final case of permutations to look at, this case 4. We're going to order objects, but instead of putting them in a line, we're going to put them in a circle. So around the table or something like that. So what is the difference between the two? It really comes down to just the first object. You see, if I've got a line, so here we go, we're going to place them in a line. Then there's a definite start to the line and finish to the line. So I could number them and say, oh, that's position 1, that's position 2, and so on. There's a definite order to it. So to place the first object, I've got 6 positions, whether it's the first spot, the second spot, the third spot, and so on. Now when I come to a circle, that's not true, because whilst there are still 6 positions, which one's the first one? And which one's the last one? I mean, there is no definite start or finish. So when we go to it, we do not have this definite start or finish. So where you place the first object then defines the positions. So it's not until you put this object in there. Let me show you what I mean. So line and circle. Number of arrangements. So if it's a line, there's n possibilities because there's n spots. You could put it in the first spot, the second spot. But when it comes to a circle, there's only one spot for it to go, and that's in the circle, because the spots are not defined. Then once that is in the circle, now you can define the spots, because you can say, oh, what if the first one after that person, or the second one after that person, and so on. So the second objects now stay the same. Well, there's now n-1 spots I can go to, and n-2 spots I can go to, all the way until we put the last object in. That means basically this. The number of arrangements, if we're now in a circle instead of a line, it's still n factorial. But I'm going to divide it by n, which was the number of ways of that first object. Because now there's not n ways, there's just one way. Well, that can be tidied up even more. Because if I roll out the n factorial, I can cancel the n and I get n-1 factorial. So it simplifies down to just that. If you want to place objects in a circle rather than a line, then you just take one off. We've got a meeting room. It's got a round table in it. It's got 10 chairs. Committee of 10 people, including 3 teenagers. How many arrangements are there in which all 3 of the teenagers sit together? We still look after the restriction first. The teenagers are going to be together. 3 factorial ways of doing that. They're not in the circle yet, so it's like a line. 3 factorial. But now it's times 7 factorial. Why? Because we've got 8 objects now. 8 objects. The group we just formed of the 3 teenagers, plus another 7 people. So there's 8 objects. But now we're going to put these objects in a circle rather than a line. So instead of 8 factorial, it's 7 factorial, 1 less. So we get 30,240. We're now going to hold elections for the chairperson and the secretary of this committee. So they're in the circle. What's the probability that they're seated directly opposite each other? Probability question. So number of ways without restrictions. There were 10 people we're putting in the circle. It's in a circle, so it's 9 factorial, not 10 factorial. Let's now place the chairperson who all of a sudden has got very full of themselves and is calling themselves president. How did that just change? Okay. They can sit anywhere. Right? No one's in the circle yet. So bang, they go and sit down. The secretary though has to sit opposite. So they now only have one choice as well. They've got to sit opposite where that president chairperson sat. Now we've got to place the other 8 people. But because there are 2 people sitting in the circle, the positions are now defined, so it is 8 factorial. It's only if the circle is empty that we take 1 off. So 8 factorial. There's our probability, which cancels down to be 1 in 9. Sometimes logic works a lot better. Just think about it this way. Well, hang on a sec. The president's going to sit down, and there's 9 seats now for the secretary to choose from. Only one of those seats is going to be opposite. So there's a 1 in 9 chance you get the same answer. So, as I say, sometimes just using logic can get these questions out quicker. Let's try an HSC one. 7 people seated around a table. How many are possible? So there's no restrictions here. 7 people, but we're going in a circle rather than a line. So it's 6 factorial. Two people, Kevin and Jill, they refuse to sit next to each other. How many arrangements are now possible? These ones where they refuse to sit next to each other, there's so many different possibilities. It's usually a lot easier to work out how many ways where they are together and then subtract them from the total amount. So okay, let's work out how many ways they are together. So in their own little group, 2 factorial. Two people being arranged, 2 factorial. Now we're going to place this group of Kevin and Jill plus another, we got 5 people. So 6 objects all up, but we're putting them in a circle, not a line. So it'll be times 5 factorial. So we get 240. Total arrangements therefore, we subtract, so there must be 480 where they're not together. This is just a little, I guess, flow chart, if you like, of how we approach these problems, because like I said yesterday, the questions you're going to have to work out which technique to use. Is it a permutation? Is it a combination? Do I just use the basic counting principle? So how do we work it out? So we come along and we go, is it a perm or com? See the difference with the basic counting principle and perms and coms. Perms and coms is when it's without replacement. As soon as you're using the same object again and again, then it's just the basic counting principle. You've got to go with that. So that's the first decision. Then we say, well, have we got restrictions on it? So if it hasn't got restrictions, then we'd go, is the order important or the order not important? And that breaks it down. Is it a permutation or a combination? We've decided the order is important. So we go, okay, now we can say, am I arranging in a line or am I arranging in a circle? Now when it comes to a circle, the sort of problems we're going to see pretty much stops there. Yeah, there might be some trickier ones in the textbook, mind you. But when it comes to a line, are we going to use all the items or are we only going to use some of the items? And then if we are going to use all of them, are some of them the same? So it's like those word problems. Or is every item unique? So that's sort of the thought process when approaching these problems. Alright, so 14G.